objectives for today, what to master for the most part. There are a couple different things, but we're going to make sure to hit domain is a big one, and that's going to be a big one for the entire year, which is why I spent so much time introducing that. And then we also need to think of f of x notation. Also, speaking of f of g of x, compositions, etc., that's coming. Fog. Did Mr. Che ever use fog? F-O, like a little baby O and then G? No. We'll see it, and when we see it, we'll be good. Here we go. Domain. Why do I have this page up at the same time as having that page up? Kind of plug it in, plug it in. Like if one of these lines up with one of these cases, we're going to basically plug in. Like this is a memorizing kind of thing if you're a memorizing kind of person. In math, if you need to memorize, this would be like make flashcards. Whenever I see a root, domain, think this. Whenever I see a denominator, domain, think this, right? If you're not a memorizing kind of person, you just need to do lots of problems so that it sticks in your brain. And if you're someone who's in between, you got to do both. Well, actually, we all need to do both. But some of you don't need the flashcards. Let's just say it that way, okay? As long as you practice enough. So on letter A, does letter A go into any one of these cases? Huh. Well, what do you do for letter A? We had an example like it yesterday. What do we do when there were sets of points and I was asking you for the domain, aka all the possible x values? Listing all of the x's. So what are all the x's for letter A? Yeah. So my domain is x equals -3, -1, 0, 2, 4. Anything else? No. Why? Because it was just those points. Those points and only those points. -3, -1, 0, 2, 4. Now hold on, pause. If this was a problem in your homework, what should be written on your paper as you solve it?
Domain.
Good. Find domain. Great summary of directions. The points, the functions. So A should have each of the points listed before the answer. B should have the function before the answer. C should have the volume formula, maybe not the wording, but the volume formula before the answer. D should have the function before the answer. So find domain, listed answer, listed answer, listed answer, listed answer. Okay? Wait. What about if in homework there are sketches of graphs? Like there are graphs you're supposed to be using. Is that part of the problem? Yeah, you gotta sketch the graphs. What if it's a vocab term at the beginning of the homework? Just put the word, ignore the O. Put the word with a quick summary of what you're answering. In the one homework, it was parallel. I think something had to do with same slope. Things have same slope. They're parallel. Right? Have opposite reciprocal slope. You can shorten this at the beginning of the homework, but if you don't list it, you're not. Are we tracking? This up? Because I caught up on grading. Oh, actually, I apologize. It might not be on RunWeb yet, but it is Google Class. Go check out that I've put on 1 and 2, and now I think I'm almost done with 3. Okay? Homework 1, as long as you fully attempted it. Number 2, I had to start, ooh, you're not writing directions. That'd be this part. Ooh, you're not writing problems. That would be like stating this part. Does that make sense, the words I'm going to be using? Okay, so directions are the beginning part. You don't have to write everything. I just need to be able to pick a random problem and know what's going on. Oh, you were doing this. I see the direction. Oh, this was the problem. And then to see the work that you put in. Okay, so these first few, I'm being really detailed just so that you know exactly what you're supposed to be doing before the big check on test day. But then as the year goes on, I'll probably just be checking like 3 or 4 preset ones that I've already chosen in the homework. And then when I look at that one, I better see directions to it, I better see the problem to it, and I better see the attempt. What if you didn't know how to attempt it? I should see absolutely nothing, no directions, no problem, and no try? No, I should see the directions, I should see the problem, and I should see some sort of question mark with some sort of like don't get directions. What does orthogonal mean? That's just an example from second semester. What else? Confused on answer. Maybe you disagreed with the back of the book or disagreed with Calc Chat. Just a quick little summary of why didn't you get it. Don't like word problems. Okay, not sure that's good enough to skip it, but at least you're being honest. Like, I might not take off as much because at least you're being honest with why you skipped it. Okay, but I need you guys to take ownership of, I'm skipping these problems and here's why. As opposed to, blank, 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 and a couple filled in. That's not a good attempt to me. Does that make sense? Okay, check out the comments on Google Classroom. We're back. Thank you, thank you, thank you, thank you, thank you. Letter B. Does it fit? One of these over there. Yeah, which one? And just like Robert said, help us out. You were like, plug in. What can we plug in for letter B? Yeah, x plus 5. Keep going with the pattern over there that's highlighted for this case. Can anybody help them out? Not equal to 0. What are you plugging into? You're plugging the argument in the denominator space. You guys need to come back over here and erase. Denominator can't be 0. If that's better in your brain, then write it down. Whenever you have a fraction, denominator can't be 0. And as you guys look at this, well, if x plus 5 can't be 0, then what can't x be? X can't be negative 5. Now, what does that statement actually mean? The domain for this function are all values of x such that x is not negative 5, aka x can be anything but negative 5. So it's all real numbers except. But if you state this one little inequality, I understand that. I get that it's anything else except for. Okay? We're going to come back to letter C in just a second. Hopefully you guys skipped a line. But letter D, which case does he fit under? Root. It's a square root because there's an understood too. So then you guys take a second, plug in. Take a second, plug in. Yeah, let's go ahead and open up our notes, okay? There you go. We're in section 1.4. Good. Lacey, is everything okay? Is everything okay? Okay. All right, so you guys are trying this one. So you're matching up with a case. Kyle just said root question mark, and I said good. So plug into, just like we did here. We had a fraction. We plugged into the clue that said take the bottom, set it not equal to 0. Good. So same thing. Oh, your right hand. Got it. How long are you going to be in the for? Oh, okay. I didn't know if you were having to not right. So then for letter D, you're plugging into the form. A couple more seconds. All right, Austin, what'd you do? Then what'd you do?
Then I subtracted 4.
Both sides?
Yeah.
Good. Good. Now pause. You might have done it totally right, Austin, but let me ask someone else. As far as I go to do the next step and I have the x, is there anything I have to watch out for or be careful of? Go ahead, Kyle.
Well, you have to, if you divide by a negative, the inequality has to switch.
Good. Why is it only when we divide by a negative that we have to flip the inequality? Do you remember when else we do? Tony, you were trying to help out. Multiply. So it's whenever we multiply or divide by a negative, we always have to flip the inequality to go the opposite direction. Now, if you notice, I didn't flip it earlier when I subtracted. That's fine. Subtraction's no big deal. But when you multiply or divide by a negative, that's when that inequality has to flip. That's something from probably pre-algebra, algebra 1, right? Just is really easy to forget. So at the end of the day, what's our domain? This puppy right there. So who did I skip and why? Yeah, anybody have an idea as to why I skipped C? It doesn't fit into case 1, 2, or 3. It doesn't have an x or y. I think, Tony, that was you, right? It doesn't have an x or a y. Maybe we need to use our logic on this one. What do they tell us this formula is for? Volume of a sphere. What kind of object is a sphere? Is it an imaginary one or a real one? All right. So if it's a real one, it has to have like real measurements, right? Okay. So if we're thinking domain of a sphere, do you think we're asking about the R values or the V values? Why R, Tony?
If you're asking for the values, it's like y.
Yeah, yeah. So if you guys are looking at this, the V is going to be like our Y or like our dependent variable, and our R is going to be like our X. Kind of like how we were doing the can, and there was V as a function of R, V as a function of H. So V is a function of R. We're thinking about our R values, and we don't have really any math to help us. In the sense that we can't just go to one of these preset domain memorization thingies. We didn't do an example like it earlier in the notes. So then logic is going to have to dictate. In order to have a sphere, what has to be true? Johan, what do you think? Good. Yeah, it has to be an actual object. A negative radius, how do you have a black hole? I don't know what's going on there, right? So no negatives. I want to add anything else as to what's not allowed? No zeros. Because if your radius is 0, what do you not have? Yeah, you have a point, a dimensionless point. Well, all points are dimensionless. It has no space to it. It's just like a location. That's a whole other thought. But R has to be, well, how do we say that with an inequality? No negatives and no 0.
Greater than 0.
Good. Why wouldn't we do like greater than 1? Greater than or equal to 1. Why not greater than or equal to 1?
Because you still have the point 1.
Yeah, what about if the radius was 1/2 or 1/3 or 1/4 or 1/10, right? 0.1, 0.01. The infinity in between 0 and 1 can't be discounted. What? Fault in Our Stars? Never mind. Does anybody know the mathematical reference? Just kidding. Talk about uncountable and countable infinities in there, just like a quick little snippet. It's interesting. Okay, so different domains, right? Sometimes x's are just little values, and there's like a finite number, so we just list them. Sometimes there's, for all of these, an infinite number, and so we try to describe them. This is everything but. This is all values, not 0, not negative. And this is going to be everything less than or equal to. You can think about number lines if that helps a little bit, but I think these are key. Whenever you have actual equations that aren't like geometric, real-life application-y sort of things, but like letter B and like letter D, it makes life so much easier if you can attach this to a case that has a set clue that you always do. And if you have this that attaches to a case with a set clue that you always do. And the one example that you didn't see yet are logarithms, but I told you that. We were kind of doing that a little bit early anyway. So let's go ahead and let's go ahead and go on to a new section. Let me go ahead and go back to one page. So that's domain. All possible x values. How do I remember range or y's? Rangy. Little baby cute rangy. Although he's not baby, he's not cute, but oh well. It's fun when things are ironic every now and then. Rangy. Set of all possible y values for a function. Here's the sad thing. In Algebra 1, I did a horrible job of explaining to Algebra 1 kids how to find range of equations. I could tell them how to do range of graphs, and I'm going to give that to you right now. We wrote down for domain how left to how right. How left can the graph go to how right can the graph go. What do you guys think if we're now talking about y values, how I'm going to write that one in?
How high, how low?
I am going to say how high, how low, but why am I going to flip the order and say how low to how high? Yeah, I'm going in order of numbers, like a number line. If you read a number line, you're going from left to right, so we're going from lows to highs, even when we're doing left and right. So we need to go from lows to highs when we're talking about y values. How low to how high? How low to how high when you're looking at a graph? Now here's the struggle with range. I mentioned this just quickly, briefly yesterday. It's the harder of the two because in some way, shape, or form, you kind of just have to In some way, shape, or form, you kind of just have to think about a graph. So let's go ahead and start with a graph, and then I'm going to have you guys think about the function attached to that graph, and we'll see what we can do. Okay? So what if I was to give you the graph? Go over, I don't know, like 3. And I want you to put a point at 3, 0. And I want you to do swoop, there it is, concave down, going forward to infinity. No asymptote. It's weird. There's a point and it just stopped. I'm going to give you the function for this graph in just a second. But first of all, for right now, looking at the graph, just a quick review, what would you guys say the domain is? Good. Good. I heard it from multiple sources. X is greater than or equal to 3. Because you can say, how left does it go? 3. How right does it? Greater than, it's above. How left does it go? 3. How right does it go? Infinity. Oh, so it's everything greater than or equal to. It's not a whole. It's a filled-in point. But what's the range? Greater. Thinking how low it goes? Like tick marks on the y-axis, how low does it go? What tick mark is here? It's not up, it's not down, it's there, it's 0. But then it's allowed to be 1 or 2 or 10 and everything in between. It's going to go slowly. It's going to go super slowly. But it is going to go on increasing, asymptotes. So therefore, y is? No. Now here's the dilemma. This is the domain and this is the range. Let me show you guys the function for this graph. Maybe some of you already know it. Does anybody already know the equation for this graph? Tony?
Y equals the square root of x.
Perfect. It is y equals the square root of x minus 3. I could have played around with it just a little bit because I didn't actually show you points, but the best guess that I would have put also is y equals the square root of x minus 3. So looking at the equation itself, does anybody have any ideas about how we could have gotten the domain? Could we have figured out the domain from that equation? Yes, but can you explain why? Kathleen, how could we have figured out the domain? Good. It's in the roots category if you guys want to look under domain problems. And then what would we have done then? And when you would have just gotten x. Okay, so domain, it's right there staring at us in the equation, waiting for us to recognize it's a root, has to be positive, cool, set that greater than or equal to 0. That meaning just the argument. But range. How do you see the range? Flip the x and y would give us y greater than or equal to 3. We don't want that. Creative, keep thinking. How in the equation could we have figured out y is greater than or equal to 0 without the graph? Tony, what are you thinking? You could have thought with this one, everything starts at 3, so couldn't you have plugged in 3 and realized, oh, 3 is a 0 of the function, 3 is the intercept? And then couldn't you have checked values for the domain? Couldn't you have made a little table and been like, all right, I don't know. What's going on? So start at 3, go to 4, go to 5, go to 6. Plug in 3, you get 0. Plug in 4, you end up with square root of 1 is 1. Plug in 5, you get something gross. Plug in 6, you get something gross too. But either way, you're like, I think all the y's are going to be positives. And it was allowed to be 0, so positives equal to 0. Okay, sounds good. But do you see how the graph is so much easier? How low, how high? Oh, how low? 0. And everything greater. Cool, done. So here's the dilemma. The easiest way to find range is with a graph, but sometimes the hardest thing to find is the graph by hand with a calculator. So range is not easy, even though maybe some of you know that all square roots will always pop out positive numbers because a negative will never result in a negative. And there's no plus or minus in front, so all radicals will only get us zeros and positive numbers. So maybe some of you could have algebraically figured that out, but almost all of us, the graph is so much easier. So the good thing is in chapters 1, chapter 2, and even kind of chapter 3, we are working on graphs. So range is one of those things you're not going to have mastered yet until you have mastered how to graph complicated functions. Does that kind of make sense? And you won't even totally master that till calculus. So it's okay for you not to be masters at range, but you do need to be able to at least look at a graph and answer the question how low, how high as best you can. And if worst comes to worst and you're stuck on a function, go to your calculator, get a graph, and see if maybe that'll help you out. Okay, domain, check. Why wasn't range up there? He's good. We talked about him. We did a little bit of him, but you're not going to have him mastered yet. Not yet. But practice with your range looking at graphs. But the next big idea, f of x notation, and here we go. Function notation. It's something that in some ways is meant to be fairly straightforward, and yet it's difficult. It's not supposed to be. I think some of our brains just kind of make it harder than it needs to be. Have you guys ever done that? Whether in like writing an essay and getting stuck, or a homework assignment where you thought the teacher was asking one thing, you did something else, or a decision you spent way too much time like agonizing over that you didn't need to. A conversation with a friend, you're like, oh, I think they meant this when they texted me that, and then it's, oh, those go downhill fast. And you find out they didn't even mean any of that. Well, or maybe they did, but sometimes our brains just go into this weird, let's just make it way harder than it needs to be mode. So I'm going to try to make this as simple as possible, but I don't want you guys to think, oh, this is easy, why can't I get it? Okay? When we're thinking about equations, I want us to think about inputs are x, outputs are y's, and the equation is going to be some sort of y equals f of x. Okay, the input is going to be x, the output is going to be y, and the equation is y equals f of x. That's basically all that we've really worried about up until now. The name can be an f, can be a g, can be an h, can be a who knows what. There are all these different names of functions. We can especially, the graphing calculator, y1, y2, y3. But we're doing function notation, f and g and h and maybe not I, because he's imaginary. J, K, L. Probably not E. He's a number. But we have these names, but then there's a notation that says, hey, let's put the name together with what kind of function he is. And so we're talking about this actual notation is f is a function of x. No multiplication, none whatsoever. No multiplication in that notation. It's literally saying, hey, this dude f, he has x's in him. In what? Oh, in his equation. Oh, okay. That's all f of x means. This dude f, he has x's in him. In his equation. Now what's going to change if our input changes to something like maybe like 2x? Our output is still going to be a y, but now if we use the equation, we have to say, oh, wait, our input isn't x anymore. It's going to be f, there's this dude, but now he's going to be in terms of not just x, now he's in terms of 2x. Or if the input, we were supposed to be plugging in something like x squared minus 1. Now it starts to get nastier, except it's the same exact thing. The output's these y's, and these y's come from, hey, this dude f, now he's plugging in x squared minus 1. You can put whatever you want in there. If I was in Algebra 1 right now, which I'm not, but that's okay, we can pretend. I could even do something, I'm going to do something easier. In Algebra 1, I would totally do like a cow, because I had a cute cow face. But we'll do a cat instead because he's easier. The cows I try to make, and it's just horrible. What if there was a cat and it was the input? What's coming out? It's still a y. And there's still a dude f. But now what's going on inside?
Cat.
Now you're going to put cats in wherever they are. Now is that very practical? No, probably not. But still the idea of, I don't care what the input is. It just needs to get put in this notation of, hey, this guy f, now he's in terms of, or he's in putting in, inputting, or inputting 2x, or inputting x squared minus 1, or inputting cats. I don't care. Careful with inputting cats. That can turn you into a crazy cat lady. But coming back. The input can change. But in the notation, nothing changes except what is being put in. Still have y's coming out of this guy f, who's a function in terms of. Now, what don't you see here at all? Actual equations. This is all just notation-y stuff. So let's go ahead and get some examples of what's going on as far as, okay, let's take an actual equation. All right? This one, f of gray box. Okay, fine, whatever. Gray box squared minus 4 gray box plus 7. F of gray box equals gray box squared minus 4 gray box plus 7. You guys know there are actual apps that calculate tip? People are lazy, but that's okay. They calculate tip. So if you, right? Tip calculators. What do tip calculators do? They have programming. And what's the programming do? The programming is some sort of, hey, input, give us how much you paid, how much is on your bill, and we'll do this little equation behind the scenes, take what you gave us, put it in the equation, and give out the tip you're supposed to pay for 10%, 50%, 20%. Now, like at restaurants, they just have a little slide thing with a little at the table, and you can see what different percentages they are, right? If they have those little like order at the table thingamabobs, and you go to pay your bill, then it's like, hey, do you want to pay 10%, 20%? There's little slide rules that tell you how much. It's but it's using the same thing. It's like based on your bill, which is unique to the other guy's bill next to you and the other guy's bill across the restaurant, you can all put in your amount, input how much you paid, and this programming says, sweet. You can just think of this kind of like a computer program. I'm leaving these fields blank. You tell me what to put in, and I'll do it. I'll put it in, and I'll simplify. I'll solve. For that, it's solving for tip. So it doesn't matter, even though we're so used to x being the input and y being the output and y equals f of x. And we could have written this with f of x equals x squared minus 4x plus 7. I just need you guys to realize whenever you see these x's, they're really just blanks. They're really just boxes. They're really just give me something and I'll put it in. So in this one, who are you supposed to be putting in? -1. So f of -1 is going to equal who squared? -1. Minus 4 times who? -1. Plus just 7, because 7's on its own. We're not doing any multiplication. We're not changing. We're taking the pattern. We're taking the formula, which technically could have been f of x equals x squared minus 4x plus 7. I'm going to rearrange this just a little bit so it looks nicer. Even though I want you to be thinking about it like boxes, in all reality, you're going to see it like this first. And I know for some of you, you're like, this is easy. I got this. Like, this is Algebra 2, Algebra 1 kind of stuff. And I get that. I really, 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 really do. And yet I mark so many points off again and again and again and again and again in pre-cal, and I don't want to. Because kids haven't fully mastered function notation yet. So you're going to see it like this. Okay, but I want you to think about it like this. Just little like, hey, input something, input something, input something. Okay, I did, -1 and -1. So what's your job to finish? PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. What does PEMDAS say? What's the very first order of operations? What's the very first thing we should do? Parentheses. Now, parentheses, is there anything inside parentheses to do? No. So number 2, exponents. Who's being squared? That guy. So I have +1. Now, technically, as we move left to right, and if there are no more exponents, technically, what are we allowed to do after exponents? Division / multiplication, multiplication / division. I have a multiplication right here. What's 4 times -1? Well, 4 times -1 is -4, and I have minus. So minus -4 will turn into adding 4. And then I have this +7. So now we're down to addition, subtraction, left to right. 1 + 4 is 5, + 7 is 12. Dun, 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 dun. Wait, so what's happening if they want the function in terms of t now instead of x? Just plug in t. And we could do it with the parentheses just to make sure everything makes sense and say, oh, t is supposed to be going in the squared spot, and t is supposed to be going in the -4 times spot, but t doesn't go anywhere with the 7. But to rewrite it, this one's pretty basic because it's just like, well, square the t, cool. Multiply the 4 and the t with a minus, cool. the exact same thing, just with a t plugged in. Now, most of you, unless you just have a propensity or just every now and then you make mistakes on negatives, etc., most of you should have been okay on A and B. But letter C is where, so many mistakes happen. So many. But check it. What do we do when they ask us? Now, hold on. You guys read it to me. Read it to me all at once. Hold on. Wake up your group. Make sure they're tuned in. Read it to me all at once as to what this is saying. Now, if you're like, wait, I don't know. On the page before, didn't I write in words what the notation means, right? Okay, so check that out. I want you to read this to me. Okay, on the count of 3. 1, 2, 3. Okay, a couple different ways. F is a function of x plus 1 or f of x plus 1. I heard both. Good. Some of you were trying the longer one. Good. Some of you were like, ooh, short. I like short. Okay, f of x plus 1. There you go. I used to be a long time ago. Anyway, so probably, right? I was born and then somehow I got here. And height is a continuous function. I had to hit everything in between. In math, we'll actually learn there's a theorem for that, intermediate value theorem. If I'm 6'2" now and I was never 0. I was 1.5 foot maybe? How long is a baby? 17 inches? That sounds like something. Anyway, if I was, let's pretend, 17 inches and then 6'2", did I have to be 4'4"? See, I was short. Okay, so coming back. I was probably just on the upper end of whatever class I was in. But, okay, f of x plus 1. Mrs. Nichols' chapel yesterday, struggle is real. Okay, f of x plus 1. Where do we put x plus 1? In the parentheses. And where do the parentheses come from? Every location of x. So then x plus 1 goes in the gray box. X plus 1 goes in the gray box. Here's where a lot of kids get confused. Either up here, thinking about every x in every equation as having parentheses around it. Thinking about every x in every equation as having parentheses around it, number 1. And number 2, here's the second common mistake. A binomial squared. Number 3, the third common mistake, this little negative. So much so that I made puppies dying every time you incorrectly square a binomial. Every time this happens, guess what I have to do? Well, I don't have to kill a puppy. The puppy's dead and you did it. I have to say, illegal, and then I put a little puppy with little dead eyes. There you go. Why is this wrong? So many of you do it. Because why? It's not foiled. You're like, oh yay, square the x, square the 3, done, 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 done. I am not even just lazy, just I forgot. X plus 3 squared is the exact same thing as, not that you have to write it out, but to be honest, when I taught Algebra 1, I taught them to write it out because I'm like, make sure you know what you're doing is right. And then when you do FOIL, are we okay if I do it fast? First, outer, inner, last. We do not get x squared plus 9. What do we get? The trinomial x squared plus 6x plus 9. In the first, doubling during the last. It's just FOIL. Now, what's that mistake with the negative? Poor little baby seals die. Look at that face. Ugh. Because if we were to take what you see over there, the negative 4, or actually the example up here, 7 minus x squared plus 2x, and if I were to make you slow down, sitting right over you, and you wrote that, and I'm like, are you sure? You're like, oh, okay. I know you guys know how to do most of this. Oh, there. If you were to say something like that, what would I have to do? Illegal. Seal. Dead eyes. Exactly. Seriously, though, right? You thought plastic was bad in the ocean. Anyway, so. Straws. Come back. Right? You just go too fast, and you don't think about it, and you don't go carefully. 7 minus 2x. What is this to prove the point of? Can you guys please simplify that? Simplify it correctly? Go. And if you did already simplify it, make sure you simplified it correctly and no poor animals died in the process. Yeah. Remember those films at the end? Animals are not supposed to be harmed in the doing of your homework. Well, let's see if you guys can make it match. Did you kill something?
Yes, I killed something.
Oh, don't kill anything. X squared minus 2x plus 4. Who has the foiling of x plus 1 quantity squared? It's okay. It's okay. Do what you gotta do. Adam, what happens when you do x plus 1 squared? Good. Do you guys agree? Plus 1x plus 1x plus 1? X squared plus 2x plus 1? Okay. What happens as we go to the next piece? Gavin. Good. So now we can say the x squared, no other like terms, got it. The 2x and the negative or minus 4x is negative 2x, and the 1 minus 4, negative 3 plus 7. 1 minus 4, negative 3 plus 7 is 4. Sorry, my brain got stuck. I don't do it in that order. Does anyone else take the positives? 1 plus 7 is 8, minus 4 is 4. Not that I do, but got to be careful of your signs, but there we go. Function notation, is it meant to be hard? No. Anytime you look at an equation, you put little parentheses around the x and say, oh, those are my gray boxes, and I fill in whatever I need, whatever they ask. So what is this not? It's not multiplication. How do we read each of these? The shortcut way? F of x is x squared minus 4x plus 7. F of negative 1. F of t. And f x plus 1. It's saying, hey, new input, plug them in, please. Okay. So question, what happens if they give you something like a piecewise function, and they say, okay, the function's more complicated, and please go ahead and find f of negative 1, and f of 0, and f of 1. How could this get any harder? Kind of. We just plug it in, but what we have to be careful of is where we plug it in. Good, it has to be the true piece. Think about the x. Gavin's trying to say, like, check out the x, and then compare to the inequalities, I think, right? As to which one's which. Now, hold on. Is it okay if I put my little parentheses around the x just to remind us of where we're plugging in?
Yes.
But are we plugging into both every single time? No. Because the first one, x is who? It's f of negative 1. And negative 1 is the input, so which statement is true? Negative 1 less than 0 or negative 1 greater than or equal to 0? Less than. So where is negative 1 being plugged into? That guy. 0, what piece is he? The first piece or the bottom piece? Second piece? Second, because the or equal to, right? So then that's going to be plugged in to the minus 1. And then where's the 1 get plugged in? First piece, second piece. Because 1 is greater than or equal to. Let me leave it up here just for a second so you guys can see what I did. Piecewise functions have different pieces of it that are only true for certain x values. So we have to consider sometimes when we're plugging into piecewise functions of, oh, what piece do I go into? And then once you figure out the appropriate piece based on the inequality, just make sure you plug it in the right spot, and then simplify solve. And 2. Negative squared is a positive. Positive 1 plus 1 is 2. 0 minus 1, negative 1. 1 minus 1, 0. We have one last topic of the day. And it is going to challenge your ability to do function notation like nothing else in this section. It comes at the mark. It's called the difference quotient. And it's actually a calculus formula they use a couple times at the beginning of the year. And they have to kind of remember the whole year through. It's an important formula in calculus. We're not figuring out what it means or why it's there or how they use it. All we're trying to figure out is, could I do the function notation plugging in that's being asked? And the function notation that's being asked is the following. The entire formula, write it down, the difference quotient, is based on, can you do function notation? The entire formula is based on, can you do function notation? So as you guys write down the formula, I'm going to do an example, solving it through fairly quickly, but showing my work as to how to plug in properly and what happens. And I want you to take that example to homework and see if you can repeat it. Come tomorrow with questions. I won't take off points if you get stuck on the difference quotient at the very end after you try it once. But let's see if you guys can follow what I do and how I plug in to this formula. Big old mess simplifies down to be quite nice. But it's hard. Take a picture of it. If you need to leave, that's okay, and still copy it in your notes. They'll be on the video or online if you need to access the notes. But take my example at the very end of homework. Line it up to the problems that you have to do and see if you can master the function notation necessary to solve it. All right, cool kids, I'll see you tomorrow. Difference quotient, do the best you can on at least one. And if it doesn't match up, you're allowed to stop there at the very end. Bye, guys. Bye, see you later. You guys got it all? No calculators left behind? Okay. Oh, in the books. It's so easy to do. You're just going and don't think about it. Got your cord? Good.